Hello and welcome everybody to another episode of Books and Bytes. Today, we're going back in time to 1904 to look at Radioactive Substances by Madame Curie.
Oh yeah, this book is incredible. It's really her doctoral thesis, so it lays out all of her research that led to the discovery of two new elements.
Polonium and radium. So
Exactly.
not just a scientific paper, but a really personal account of a huge scientific breakthrough.
And it offers a glimpse into what it was like to be a woman in science at the time, which was not easy, let me tell you.
So let's dive in. What are some of the main themes that she's tackling here?
It's really all about the nature of radioactivity. She lays out all of her investigations, experiments, the conclusions she makes.
This is what and the how.
Yeah, exactly. And her approach is so meticulous, so detailed. It's really a testament to scientific inquiry and to just plain hard work.
Can you give us a quick overview of the structure of the book?
So she starts by building on Henri Becquerel's work. He's the one who discovered uranium rays just a few years before. And she investigates uranium and thorium compounds and confirms that radioactivity is an atomic property.
So this is the foundation of nuclear physics as we know it.
Yeah, I mean, she's really laying the groundwork here. But then she makes this key observation. She realizes that pitchblende, which is a uranium ore, it's way more radioactive than pure uranium.
Interesting.
So that leads her to think that there are other undiscovered elements lurking within the pitchblende, elements that are even more radioactive than uranium.
It's like a detective story.
Yeah, she's on the case. And the next part of the book details her journey with her husband, Pierre. They work to isolate these mystery elements.
Incredible.
Through tons of chemical separations and measurements, they finally extract polonium.
Named after Poland?
Yep. And then radium, which glows in the dark.
Wow.
Amazing stuff.
So groundbreaking.
And then she goes on to explore the different types of radiation that these substances emit.
This is where we get alpha, beta, gamma rays.
Yeah. I got it.
So she's really starting to define the field here.
And her methods are just so meticulous, her descriptions are so detailed, it makes this book a cornerstone of modern physics.
Let's dive into the details. So she's building on Becquerel's work. What was the state of knowledge about radioactivity at the time?
Well, the late 1800s was a really exciting time for science. It was just a few years after Wilhelm Röntgen discovered X-rays, which, could pass through solid objects, so everyone was really interested in these new mysterious forms of energy.
Like a whole new world opening up.
Yeah, and then in 1896, Henri Becquerel stumbles upon something even more strange.
So he's investigating uranium salts.
Right, and he finds that they emit these rays that can expose photographic plates, even when they're wrapped in black paper.
So like X-rays.
Similar but different. It was a really strange observation.
I feel like so many big discoveries happen that way.
Yeah, you're looking for one thing and find something totally unexpected.
So Curie picks up where Becquerel left off.
Yeah.
What's her initial approach?
She was fascinated by his discovery, and she really wanted to investigate uranium rays more systematically. I think she sensed that this was something big.
Like a revolution in science.
Totally. Her first investigations focused on measuring the intensity of the radiation from different uranium compounds.
And this is where she starts to use the electrometer.
Right, to quantify the strength of the radiation.
So she's going beyond just observing.
She's measuring.
Yeah.
And what she finds confirms Becquerel's work. Uranium compounds emit these rays spontaneously. It seems like there's no external source of energy.
That's pretty mind-blowing.
It was. It really challenged what people understood about energy and matter at the time.
It's like the uranium is a battery that never runs out.
Yeah, and nobody knows where that energy is coming from.
So what does she do next?
Well, she wants to know if this is unique to uranium, or if other elements do the same thing.
So she starts going through the periodic table.
Basically, she's examining all sorts of elements and compounds, and she finds that thorium is also radioactive.
So it's not just uranium.
Right. And this leads her to a big conclusion. Radioactivity is an atomic property.
Meaning it's a feature of the atom itself.
Exactly. It's not about chemical reactions or anything like that. It's coming from inside the atom.
Wow.
Yeah, and this discovery is just the beginning of her journey.
This is incredible. Her meticulous work and her insights. It's no wonder this work is so important.
It's really inspiring to see how she builds her case. Always questioning, always digging deeper.
So she's figured out that radioactivity is an atomic property, and she's identified uranium and thorium. What happens next?
Well, this is where things get really interesting. She's measuring the radioactivity of all these different minerals, and she notices something strange. Pitchblende, which is a uranium-rich ore. It's showing way more radioactivity than it should. based on how much uranium it contains.
That's got to be a clue.
Oh, yeah. She knows she's onto something. There's something else in that pitch blende, something even more radioactive than uranium.
Like she stumbled onto a treasure map.
Right. And that treasure is going to turn out to be two new elements.
Polonium and radium.
You got it. But finding them is going to take years of work. A real testament to her dedication.
I can't wait to hear more about that.
It's an amazing story. So Curie's observation about that pitch blende, that was a really pivotal moment. It set her on this path to discovering two new elements.
It must have been so exciting. Like stepping into the unknown.
Oh, absolutely. But actually getting those elements out of the pitch blende, that was a huge task.
What did that process even look like?
Well, imagine working in this makeshift lab with limited resources, having to process tons of this heavy black ore.
I've seen pictures of their lab. It's pretty basic.
Yeah, it was. And they had to use all these hazardous chemicals.
It's remarkable they were able to do what they did.
It really is. So they dissolve the pitch blende in acid, and then they use all these chemical reactions to try to separate out the different elements.
Each step of the way must have been so meticulous.
It was. But how did they even know what they were looking for?
These new elements, they were completely unknown.
Right. But that's where Curie's understanding of radioactivity really comes in. She realized that she could use radioactivity itself to track these elements.
So like following a trail.
Exactly. They'd measure the radioactivity of each fraction of the ore, looking for any increases in activity.
So step by step.
They started to zero in on what they were looking for.
And this is how they found polonium.
Yes. Named after her home country of Toland.
Such a momentous achievement.
It really was. But they weren't done yet. They knew there had to be another element in there, even more radioactive.
Radium.
Exactly. But getting radium out was even harder than polonium because it's present in such tiny amounts.
So even more ore to process.
It was a massive effort, years of work.
Wow.
But finally, in 1902, they isolated a pure sample of radium chloride.
I can only imagine what that must have been like, to see it glowing.
It was a huge moment for science. It not only added to the periodic table, but opened up all these new possibilities.
For medicine, industry, all sorts of things.
And all of this is in the book. Her account of this discovery is really incredible.
It must be so fascinating to read about these discoveries from her perspective.
It really is. You get to see her thought process, her approach.
So they have polonium, they have radium. What's next?
Well, now she wants to learn more about these substances, about the radiation they emit.
Some more experiments.
Oh, yeah. She's designing these really detailed experiments to measure the intensity of the radiation, how far it can travel, things like that.
And she's developing new techniques all the time.
She was a real pioneer.
And this is where alpha, beta, and gamma rays come in.
Exactly. She uses electric and magnetic fields to separate the radiation into 3 different types.
What a breakthrough.
It really was.
Can you break down those different types for us?
Sure. Alpha rays are these heavy, positively charged particles. They can be stopped by a sheet of paper, but they cause a lot of ionization.
So small but mighty, that's one way to put it.
Mm-hmm.
Then you have beta rays, much lighter, negatively charged. They can travel further. You need something like aluminum to stop them, the speedy ones.
Right. And then finally, gamma rays. These are not particles. They're a form of electromagnetic radiation, like X-rays, but even stronger.
Wow.
Yeah, they can go through several centimeters of lead. They don't ionize as much as the others, but they can still cause damage.
It's incredible she was able to figure all of this out.
It really is.
And these discoveries led to so many advancements.
In physics, medicine, technology.
Her work was really transformative.
It changed the world.
So she's explored the properties of these new elements. What else did she discover?
Well, she also investigated the chemical effects of radiation, how it could trigger certain reactions.
So not just a form of energy, but something that can change matter.
Exactly. For example, she found that radium rays could decompose water into hydrogen and oxygen.
That's amazing.
And she also found that radiation could change the color of certain substances, like glass.
Wow. It's like alchemy.
In a way, it is.
These chemical effects must have opened up so many new questions.
They did. It was a whole new area of research.
And all of this is in Radioactive Substances. It's so much more than just a scientific paper.
It really is.
It's a testament to her brilliance, her dedication,
Absolutely.
and to the power of scientific discovery.
As we move into the final part of our deep dive, we'll see how Curie's work went beyond the lab, how she started to think about the applications of radioactivity, and the implications of her discoveries. As we get to the end of Radioactive Substances, we see Curie starting to think about the bigger picture, moving beyond the lab and into the real world.
This is where we see the potential applications and the dangers of radioactivity.
Yeah, she was very aware of both.
And she knew those dangers firsthand with the radiation burns and other health problems she experienced.
That's right. But she was also really interested in how radiation could be used in medicine.
The early days of radiation therapy.
Exactly. She describes some of the early experiments using radium to treat different illnesses. She sees the potential, but also knows that it needs to be studied carefully.
So she's excited about the possibilities.
Yeah.
But also cautious.
Yeah, it's a really interesting balance.
And it's remarkable how she's able to weave these big picture reflections into her very detailed scientific writing.
It makes the book so much more than just a dry scientific paper. You really get a sense of her as a person, as a scientist grappling with these huge questions.
She's laying the groundwork for nuclear physics, but also for the field of radiation protection.
Absolutely. Her observations about the effects of radiation on the body and her emphasis on safety, those were really important in shaping how people thought about radiation.
And her work is still relevant today, as we continue to use radiation in medicine and other fields.
One of the most interesting parts of the book for me is where she described trying to figure out the atomic weight of radium.
That's a pretty fundamental task in chemistry.
It is, but it was incredibly difficult for her because she had such a tiny amount of radium to work with.
Just a few milligrams.
Yeah, it's amazing she was able to do it, but she did. She adapted old techniques and developed new ones, and she was able to accurately measure the atomic weight of radium. It really shows her dedication to scientific rigor.
And it helped to solidify the discovery of radium as a new element.
Exactly.
As we wrap up our deep dive into radioactive substances, I'm just amazed by everything Curie accomplished.
It's an incredible body of work.
From establishing that radioactivity is an atomic property, to isolating these new elements, to exploring the properties and applications of radiation, her work had a profound impact on science and technology.
And she did it all with such brilliance and passion.
It's really inspiring.
It is.
Radioactive Substances is more than just a scientific document. It's a story about human curiosity and the power of scientific discovery.
It's a story that continues to inspire us today.
Thank you for joining us on this journey. Until next time, keep exploring, keep questioning, and keep that scientific curiosity alive.